Hello everybody. I'd like to introduce you to a hack challenge in the Eclipse SDV Hackathon Chapter 2, what will be held in ICF Karlsruhe from the 20th November to 22nd November 2024. So, first to introduce myself, I'm Christian Heissenberger from Litas GmbH and I will be hopefully one of the hack coaches for you by play-by-wire. This is the hack challenge what I want to introduce to you. So, first of all, the goal of the challenge is you shall run a game on an HPC with a display. Next thing is you should receive the input of the signals from a controller, what is connected to an ECU. Then it should send the signal to a zone controller where the HPC is consuming it, and you're using Eclipse CUXA and optionally open 702022, sorry, for communication. And everything is on the HPC, should be orchestrated, hopefully with the Eclipse Ankyos project and monitored by Ankyos dashboard. And you shall run it on an Digital Auto EE Maker Kit. So this sounds very complex, but nevertheless it should be very fun. So the first thing is you see a lot of logos here and a lot of projects you heard already. You just have to scan me above right, and then you will see the full tutorial as well. Nevertheless, if I'm going forward, what I want to introduce you today. First of all, the SDV projects, because we are using a lot of projects for that one. You shall use some of them. You can use whatever you like, but of course, please try them out. Investigate, invest time, please, for each of and every project. There will be a lot of hack coaches available. They can help you. Nevertheless, the second point would be for which project you can use it for which project you use for what. So I will introduce you some examples, and with that, you will see how to use it. Nevertheless, the full tutorial is available on the GitHub repo page, of course. So first of all, we start with simulation. So we have Digital Auto in the first line with Eclipse AutoWorks. This is an open initiative to create the next generation of software-defined vehicle. And there is a playground in Digital Auto where you can test and simulate your ideas directly. You can try it out, for example, with Python code and run a simulation if this is running as you like. For play-by-wire, you can also use Flappy Bird if you like to, or Pong Game. The third thing here is the vehicle signal specification. This is not directly an Eclipse SDV project, but we are directly partnering with Covesa, so the vehicle signal specification is the way to go if we have exactly the syntax for our signals. So, as I've written it here, this is your interface for data definition. Everything what you want to communicate, define it after vehicle signal specification, then you have it much more easier to communicate with your partners. Fourth point is Velocitas. Velocitas brings you a full SDK for vehicle applications. So on top of the VSS data specification and the CUXA data broker, what is the next one, you can get it a seamlessly integrated full executable OCI container, what can run nearly everywhere. You just have to execute the right build. Then next thing would be the CUXA data broker. The CUXA data broker is very important for you because if you want to use vehicle signal specification, this is the implementation to go. And there is an CUXA Python SDK for you where you can also directly try it out as you like. Nevertheless, all those 4 and 5 projects here are seamlessly working together. If you start with Digital Auto, you can create directly a Velocitas application out of it. And in Digital Auto Playground, you can create a wish list. Remember that, wish list for the vehicle signal specification, what is directly included in your Velocitas project and what you can reuse in the data broker. So here for orchestration, there is Ankyos. So you have to have an orchestration yourself. So please put in Ankyos and watch it with Ankyos dashboard. You will find it in the tutorial page. And for communication between a zone and a sensor and the HPC, there is Open 7022. This is implementation for streaming audio and video and tunneling CAN and LIN messages through. And a very cool thing now, Eclipse ThreadX. If you like to use a real-time operation system, an RTOS, use ThreadX and you have a full, deeply embedded real-time system for your applications. And of course, there is Arduino. If you have ever worked with some boards, you cannot go around Arduino. If you see here, these small devices are very cool. Okay, it's empty, so already in use. And yes, so next thing is, how is the example done? Um, First of all, some small theory about vehicle EE architecture. You have here a front zone, a cabin zone, a rear zone. We define this as zone in vehicles. You have a lot of things here. The small blue bubbles are sensors and actuators. Then behind that you have an sensor ECU, so what is directly processing the sensor digital or analog signals. What is going through a gateway or a zone controller and communicating to a vehicle compute um, zone, where a VCU or high performance compute device is inside, with of course an IVI, an infotainment system. And you have one, two, three, four of them. Whew, that's complex because you also have CAN and LIN as a communication inside. If you never heard about CAN, CAN, it's not a trash can or something like that. It's an automotive communication area network. So coming to an easier thing, we cut down on the complexity to 3 zones and at the game. In the middle central zone, you have the central HPC, where you normally put in your inputs for the display, where you run your Pong game. I just take Pong because Pong is very easy and commonly used. And on the right side, it's the rear zone. There's a rear zone control, one sensor, one actor, and some blinking interfaces. On the left side, front zone control, only for signal forwarding, no processing, a sensor and an actor. And now, what to do? For this example, the game Pong can be played. Two-player Pong is shown on display in the middle. Then the input of player 1 is in the front zone, input of player 2 is in the rear zone. And both players have different inputs. For example, in the front, player 1 has a gas and a brake pedal for up and down of your pedal inside the Pong. Additionally to that, you have an actor, so to show the points what you have as an LED. So 8 points of LED, what is then on a different device put out. The communication to the front zone is over CAN, and the front zone control communication to the HPC is over Open 7022. And in the rear, for example, the input of the player 2 is just a small joystick what you can connect to the Arduino. And this is exactly the thing. How can you achieve that with the projects? Coming to that, you have exactly the same overview, and here you have the different projects. On the left side, for example, you have the Arduino community. So there is a board and a sensor. You can play around whatever you like. For example, a small throttle up, throttle down. In the next thing here, there could be an Arduino device as well. For example, an H7 with a ThreadX on it, or the devices what we also have there. What are the boards for ThreadX? On that board, you can open up an Open 7022 streaming channel to read in the CAN signals and push it directly forward to your central compute. Inside the central compute, you can parse it again, so directly push your signals to the Kuxa data broker with the standard of the vehicle signal specification. And you can directly process it and react on it with a Velocitas application. If you don't like to have a Velocitas application to process your signals, you can also directly use within Kuxa the Python client, what for example is used in the example Pong game. On the next side, you can then, out of the Pong game, release back your points. So the current status of the points of the player. You're streaming it through the Open 7022 to the real zone control, push it on the CAN signal to the actor that you show the points of the LEDs on the LEDs for that one. And of course, to look at the dashboard, you can also watch your workload, what is applied and managed by Ankaios. Because Kuxa and also Velocitas and also the Pong game shall run in a container what is then deployed, or a native application, Ankaios is also capable of that, with Ankaios and watch the workload on the Ankaios dashboard. This can be executed on your development PC, what is connected also to the virtual car. And of course, before you try it out on this environment, you can try it out and prototype it on the digital auto playground. Good. So this is an overview. Everything what I talked to you is directly available here on the tutorial page. So you find it here. Welcome to play by the Hack Challenge. You find all the links to all projects, examples like the joystick input, some ideas what to hack, and a small step guide how you can proceed. You must not, but you can. But first of all, it's very important to investigate your inputs, because if you have no inputs, then second important point, what game to play, like Pong, like Flappy Bird, like Supertux Kart, what is very advanced, and you have to know C++ by heart. And the third one, choose your deployment architecture. You have seen it in my presentation here. This one here is an EE architecture. It's maybe a good thing to do it and to see, okay, what is running where. Otherwise, you get completely out of sync with your team and also out of your goal. There is also an example. You can also do it in PowerPoint. Don't care. Fourth step could be create an API wishlist in Digital Auto and get your interfaces defined, because it's one of the most important jobs in an EE architecture in a vehicle. Get your interfaces under control. After that, you shall choose your proper tool to deployment, like Ankaios. And if you need help for that, maybe you can also go to the challenge Shift to SDV, because the Ankaios guys are having a very, very cool challenge there. And then split up the team and get your domains running. And this is the point. Always define teams: who is caring about sensor, who is taking care about actor, who's streaming the signals, who is displaying it, how to display, on which signal you react, and how you put it out. And who is doing what input. Doesn't matter for the Pong game if you do it right. So, happy hacking, see you there, and have a lot of fun.